Hello everyone, good evening to all of you. Myself Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today in this lecture, I am going to discuss about the solution of question bank from Module 4, and I want to discuss the part C, definitions and short answer type question from vector calculus. First of all, I want to suggest two references of textbooks which are given as below, which are very important for engineering mathematics for in second semester. The first reference of textbook is, the name of authors are N.P. Wali and Dr. Manish Goyal, publications Lakshmi Publication Private Limited. And other reference of textbook is, the name of the authors are H.K. Das and Dr. Rama Verma, publications as Chand and Company Private Limited. So now in this lecture, I want to discuss about part C, definitions and short answer type question from vector calculus. So here question 1, we want to discuss a definition, define gradient of a scalar point function. Scalar point function. So what is scalar point function? Here solution or definition. What is definition? Number 1, vector scalar point function. What is scalar point function? Scalar point function. What is scalar point function? Scalar point function, the position of a point in a three-dimensional coordinate geometry, in a three-dimensional coordinate geometry. Coordinates geometry. In scalar form. In scalar form is called a scalar point function. Scalar point function. Okay. The position of a point in a three-dimensional coordinate geometry. In three-dimensional coordinate geometry. In scalar form, position of a point in three-dimensional coordinates geometry in scalar form is called a scalar point function. That is represented by phi, and this is function. This is some x, y, z function. This is scalar, not vector. Okay. Now second result is grade of. Second point is grade of grade of scalar of a scalar point function. Grade of a scalar point function. Scalar point function. What is grade of a scalar point function? So here any function, any scalar function is given, and Grade of scalar point function means grade f. Grade f. Grade f means del f. Okay. This is known as a grade of a scalar point function. Here del is I dou over dou x plus j dou over dou y plus k dou over dou z. Del is three-dimensional differentiation vector operator, and f is a scalar point function. So del f equal to, we can write del f is I, this is vector quantity. Grade f is a vector quantity. I del f over dou x plus j dou f over dou y and plus k dou f over dou z. This is the main concept of this. Here del f is a vector quantity. Okay. Del f is a vector quantity. Del is vector, f is scalar. But the product of del and f is vector. So that is known as a grade f. Grade of a scalar point function. Now next, define divergence of a vector point function. In grade, we get scalar point function, but in divergence, we get vector point function. So here, definition, number one, vector point function. Vector point function. What is vector point function? First of all, so the position of a point in three-dimensional geometry the position of a point in three-dimensional geometry is in vector form. Or position of a point measured from origin is called vector point function. Vector point function. The position of a point in three-dimensional geometry in vector form is in vector form, or position of a point measured from origin directly is called vector point function. So now divergence of a second point, this is point 1. Now second point, divergence of a vector point function means number one point in this topic Number 1, del is present. Number 2, f vector point function. F is a vector point function, void function. Okay. Now taking divergence f. Divergence f equal to del dot f. This is divergence of a vector point function. Okay. This is in vector form. So here is del is I dou over dou x plus j dou over dou y plus k dou over dou z and dot. Next here I f1 I f1 is the covered f1 I and f2 j and f3 k. This is the vector point function f. So now del f, this equal to taking dot product I dot I. Here I dot I is 1, j dot j is 1, k dot k is 1, I dot j is 0, j dot k is 0 and k dot I is 0. K dot I is 0. So now we get here I dot I is 1. So we get here dou f1 over dou x plus dou f2 over dou y plus dou f3 over dou z. So this is the divergent of a vector point function. This is scalar quantity del dot vector f. This is a scalar quantity. Divergence f. Divergence of a vector point function is a scalar quantity. A scalar quantity. Okay. Now next one is define curl of a vector point function. So here definition. Curl of a vector point function. Curl of a vector point function. Here number 1, del is present. Okay. Number 2, f vector, this equal to f1i plus f2j and plus f3k. This present. This equal to del I dou over dou x plus j dou over dou y and plus k dou over dou z. Dou over dou z. This is del. This is f vector. So now curl f vector, this equal to cross product between del and vector point function is known as a curl f. So here del equal to del f del cross f. Here is del cross f vector. So here we can write here in determinate, here I cap, here j cap, here k cap. Here dou over dou x and dou over dou y and dou over dou z. Now here is f1, f2 and f3. So now after expanding this determinate, 3 cross 3 determinate is this. So we write here I cap. So now in bracket, this dou f3 y over minus dou f2 dou z, and minus j cap in bracket, this cancel, dou f3 over dou x, and minus this cancel to this, dou f1 over dou f1 over dou z, and plus k, and this equal to here, this cancel to this cancel, dou f2 over dou x minus dou f1 over dou y. Okay, this formula is known as a curl of a vector point function. This is j cap. So this is curl f. Here curl f is equal to I cap, and here dou f3 upon dou y minus dou f2 upon dou z minus j, and here dou f3 over dou x minus dou f1 over dou z, and plus k here, this equal to dou f2 over dou x minus dou f1 over dou y. Okay, so this formula is known as a curl f. This is formula for curl f. Number 1 point, divergence f is the dot product between del and f vector point function. Number 2, curl f the vector the vector product the vector product between del and f vector. Okay, so divergence equal to, third point, divergence f equal to del dot f, and curl f is equal to, this is del cross f. Okay, this is scalar quantity, and this is vector quantity. This is vector quantity. Okay, next is state Laplacian operator. What is Laplacian operator here? So here definition. Here u is any scalar function. Scalar function is given. Okay, then Laplacian operator is represented by del square u is equal to 0. This equal to I dou over dou x plus j dou over dou y का whole square, u equal to 0. U is two-dimensional function, not three-dimensional function. Here always be two-dimensional function. In Laplacian operator, here del taking up always two-dimensional function. So here We write here now dot product of this here. I am writing here I dou over dou x plus j dou over dou y and dot I dou over dou x plus j dou over dou y and u equal to 0. So here taking dot product between I and j, then we write here del 2 over del x2 plus del 2 over del y2 and u is equal to 0. So this implied that here del square u over del x2 plus del square u over del y2. This equal to 0. This is Laplacian operator del. Okay. Find curl f where f is this. In our question 5, there is some function, vector point function is given here. Solution here. Solution here given us that vector f is grade x cube plus y cube plus z cube minus 3xyz. Okay. This is vector point function is given. Now we have to find curl f. Curl vector f, this find. So here first of all f vector. What is f vector here? So f vector solving number 1. Solving vector f. Vector f means f vector. F vector is, this is grade x cube plus y cube plus z cube minus 3xyz. So f vector is equal to del dot. Grade means del dot. X cube plus y cube plus z cube minus 3xyz. So now here vector f is del is I dou over dou x plus j dou over dou y and plus k dou over dou z and dot f is here, f vector is, this is x cube plus y cube plus z cube minus 3xyz. Okay. Now differentiating this. So here this equal to I and dou over dou x of x cube plus y cube plus z cube minus 3xyz and plus j dou over dou y, here x cube plus y cube plus z cube minus 3xyz and plus k cap dou over dou z, here x cube plus y cube plus z cube minus 3xyz. Okay, xyz here. So now f vector is I. Here differentiating with respect to x. Y and z are constant. Y and z are constant. So here we get here differentiating with respect to x means 3x square minus 3yz plus j, here differentiating with respect to y. In second term, differentiating with respect to y, then we get 3y square minus, here is 3xyz, here is 3xyz, so y is 1, 3xz, and plus k, differentiating with respect to z, x and y are constant, so 3z square minus 3xy. Okay, this is vector point function f. F is here this vector point function. Okay, now we find out the curl f. So here curl f is second point. Curl f is del cross f. So del cross f means here I, j and k. Now here dou over dou x, dou over dou y, and dou over dou z. And now putting here 3x square, 3 is common here. 3x square minus yz. Y 3 is common, y square minus zx. 3 is common, x square minus z square minus xy. Z square minus xy. Okay. So 3, from one row 3 is common. So we can write here curl f. Curl f equal to here 3 is common. And here I, j and k. So now here x square minus yz, y square minus zx, z square minus xy. Here dou over dou x, here dou over dou x, dou over dou y, dou over dou z. X square minus zx, y square minus x square minus yz, y square minus zx, and z square minus xy. Now open this. After opening we get here 3, here I vector, and this cancel, this cancel. First row, first column cancel. So dou over dou y of here z square minus xy, and minus dou over dou z of y square minus zx, and plus k minus j here, minus j here, this is j cap, j here second column and first row cancel. So dou over dou x of z square minus xy, and minus dou over dou z of x square minus zy. Next plus k, and dou over dou z of here differentiating dou over dou x of this cancel, third column and first row cancel. So here y square minus zx, and minus dou over dou y, here y. So y x square minus zy. This cancel. Okay. So now finally we write here 3, here I, and differentiating with respect to y here. So here minus x. We get here minus x. And here is differentiating with respect to z. So here we get plus x. Okay. Now minus j. We get here bracket. Differentiating with respect to x is minus y. And here is with respect to z. So plus y. And plus k. Here with respect to z is minus x, with respect to z. This is not. Here with respect to x. So here is minus z and plus z. So now 3 into, we get here I into 0 and minus j into 0 and plus k into 0. So finally we get 3 into 0 is equal to 0. So the value of curl f is 0 here. Now next problem 6. Question 6 is find a unit normal vector to the given surface this at point this. Unit normal vector. We want to discuss what is unit normal vector. So here solution given us that here scalar point function is given. Scalar point function is given in the question. Is given. Given is that scalar point function. So scalar point function f is given here. F is x square y plus 2xz and minus 4. This function is given here. Okay. And one point. Point is given. Point is given here. So point is here 2, minus 2 and 3. We find out unit normal vector. So n cap is a unit normal vector. Unit normal vector. So definition of n cap is del f upon mod of del f at point x, y, z. General point. This is the value of n cap. This is mod at a general point. Okay. So now first of all, number 1, finding del f. What is del f? Del f means I dou over dou x plus j dou over dou y plus k dou over dou z. This is the del. And f. F is given here x square y plus 2xz. X square y plus 2xz plus minus 4. This is the function. So differentiating this, then we get value of del f. Del f is here I dou over dou x, differentiating x square y plus 2xz minus 4 and plus dou over dou y, differentiating x square y and my plus 2xz minus 4 and plus dou over dou z, differentiating x square y plus 2xz minus 4. Okay. So now here we get this I here differentiating with respect to x. So we get here 2xy and plus 2z. Okay. Now next we get here plus differentiating with respect to y here. So y is x square j, x square y and plus 0, 2xz. Differentiating with respect to z here. So we get here 2x k, here 2x. So this is the del f, value of del f. This is grade f. This is grade f. Basically this is grade f, value of f at x by z. So this is the value is 2xy plus 2z into I and plus x square j and plus 2xk. Okay. This is the grade f. This is grade f at point x, y, z. Now point is given. Then we find grade f vector. So grade f at point is 2 minus 2, 3. 2 minus 2, 3. So here putting x is 2. 2 into 2 into y is minus 2. Plus 2 into z, z is 3. And into y. Plus x is 2, so 4j. And plus z is 3, so 6k. So we get here, this is minus 8 plus 6. Here minus 8 plus 6 and into I plus 4j and plus 6k. So finally here 2i and plus 4j and plus 6k. So we get here grade f or del f, this equal to value is 2i, this is grade f. Okay, grade f equal to 2i plus 4j plus 6k. 2i plus 4j and plus 6k. Now unit normal vector. Now unit normal vector is n cap, this equal to grade f upon mod grade f. Okay, this equal to del f upon mod of del f. This equal to 2i plus 4j and plus 6k, and this upon mod of 2i plus 4j and plus 6k. So here is this equal to 2 is common, I plus 2j plus 3k. Now denominator is 2 common, so under root we can write 4 2 ka square and plus 4 ka square and plus 6 ka square. Okay, so 2 is common, we write here 2 into I plus 2j and plus 3k. Now here 4 is common, under root 4 plus 16 plus 36. So this equal to twice of I plus j and plus 3k upon. So here is 4 is common means 2 under root. This is 4 common. 1 plus 4 plus 9. So 2 is cancelled. So here upon 14 we get here n cap is equal to I plus 2j plus 3k upon root 14. Okay, this is unit normal vector. This is required unit normal vector. Okay, this is required unit normal vector. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.